1.
All right, now the meat of 8.2 is the Pythagorean Theorem. You've learned this before. You learned it in middle school math. You might have even touched on it in Algebra 1 a little bit. It just depends on your teacher. But this is something that I cannot stress this enough, is only true for right triangles. You can only use this for right triangles. You cannot use it for an obtuse triangle. You cannot use it for an acute triangle. This only works for right triangles. So implant that in your head. Right triangles only, Pythagorean theorem. Now remember, your triangle has, if you're dealing with a right triangle, it has two distinctive types of parts. You have legs, and then you have the hypotenuse. The hypotenuse is always across from your right angle. So we have a equation that we get to use, or a theorem that we get to use to help us if we are missing one side of our right triangle. Just one, not two. Obviously not three, because then I wouldn't know anything. But if I am missing one side of my triangle. And the Pythagorean theorem is a squared plus b squared equals c squared. So I take the two legs, I square them separately, then I add them together, and that's equal to the length of the hypotenuse squared as well. So you'll see some adding of radicals, you'll see some square rooting, some simplifying radicals. We're going to do a couple of different things. So let's try this out with real numbers. So for our Pythagorean theorem, let's see, I've got a little triangle here created by number blocks. So I've got my right triangle, or my right angle here. Go ahead and sketch this guy out. There we go. So I need to find the side lengths. I have, this side length is 1, 2, 3 units. And then I have 1, 2, 3, 4. And then I have 5. So we want to double check to see if this works. What if I only knew 3 and 4? I only knew my two legs. So 3 squared plus squared could equal c squared. 3 squared is 9. 4 squared is 16 equals c squared. 9 plus 16 is 25 equals c squared. To get rid of that square, we square root, and c would be equal to 5. Wow. Now this works. Maybe we know the hypotenuse and one of the legs, but not the third leg. This would also work. So perhaps we know 3. We don't know 4, so we're going to say b squared equals, but we do know our hypotenuse, which is 5, so 5 squared. 3 squared is 9, plus b squared equals 25. We could subtract that 9. And you get b squared equals 16. Got to get rid of that square, so you square root, and b would be equal to 4. So Pythagorean theorem works if you have one leg and one hypotenuse, or if you have two legs and you're trying to find the hypotenuse. It works both ways. You just have to make sure that you're adding or subtracting correctly.